Hello friends. Okay, so we'll study firing circuits of a SCR. As I said in our last lecture, there are two types of firing circuits: resistance firing and resistance capacitance firing. Now there are different advantages or merits and demerits of these two firing methods. First, we will study a resistance firing. Now the what I can say the limit of this resistance firing is we can control the firing from 0 degree to 90 degree. We can't control switching on or firing of a thyristor above 90 degree. Okay, why this is so and what is the remedy we'll see later. Okay, so here you can see a circuit diagram of resistance firing. Okay, now in this particular diagram you can see there are three different resistances R1, R2 and R, right? So R2 is the resistance which is to be varied. Okay, R2 is a variable resistance. This R is a stabilizing resistance. What it means I will tell you, don't worry. R is a stabilizing resistance, and this R1 is the resistance to limit the gate current, limit the maximum gate current. Okay, so there are these three resistances. This is a diode and this is a thyristor which need to be turned on. Okay, now consider when this resistance has a zero value, that time what will happen? Your your diode will conduct through this load R1, then through diode. Okay, and your gate current through diode, it will go through gate, through cathode and complete the path. Are you getting? This is how it will conduct. Now we should always take care that there is some maximum limit for the gate current. Okay, and we never cross that maximum gate current limit, otherwise your device may get damaged. Now how to finalize this maximum current? This maximum current should be this maximum voltage divided by the resistance R1. Are you getting? Voltage divided by this resistance R1 is the current. Now always take care that your IGM, that is the maximum gate current, IGM should be less than Vm divided by R1. Okay, IGM should be less than Vm divided by Rm. Or I can say R1 should be greater than Vm by this IGM. So this is how value of R1 is fixed. Okay. Now next resistance R. This resistance is called as the stabilizing resistance. So what it means? It means that this resistance should have a drop across it Vg, which should be less than maximum gate voltage. Okay, it should not exceed the maximum possible gate voltage VGM. Okay, if this happens, then again this device may get damaged. Okay, so how to finalize this particular value, or how to finalize this maximum gate voltage? So you can find it by voltage dividing rule. So how it is to be find it? Main voltage, that is a Vm. Okay, Vm multiplied by this R divided by R1 plus R. This should be the maximum drop across this. So from that formula, we can rearrange it to find out the R, and R will be nothing but R is it should be less than equal to Vgm by Vm into Vgm into R1 divided by Vm minus Vgm. Okay. Again, I will repeat the formula. First, I said Vgm. Vgm should be given as your main voltage Vm multiplied by R divided by R1 plus R. Now, if you rearrange these equations for R, you will get R should be less than equal to VGM, that is maximum voltage, multiplied by R1 divided by Vm, that is maximum voltage Vm minus Vg. Are you getting? Now, this as resistance R1 and R2 are large, gate trigger circuit draw very small current. Okay, this diode T allows the flow of current during positive half cycle only. Okay, and gate voltage Vg, this gate voltage Vg is half wave DC pulse. Amplitude of these DC pulse can be controlled by varying this R. Okay, so how to get it? When you vary this resistance, as this resistance goes on increasing, ultimately this gate current will reduce. Are you getting? And as gate current will reduce, obviously this drop will also be less. So firing will happens at some delay. Okay, so we'll see some diagram. See here, I have three different diagrams. This is the diagram in which your this gate positive voltage VGP. Okay, peak gate voltage. Peak gate voltage means drop across this particular resistance. Okay, drop across the resistance is a peak gate voltage. Now, if this peak gate voltage is very less, and if it is not reaching to the VGT, VGT is a threshold gate voltage. Okay, threshold gate voltage means a voltage at which, or minimum voltage at which your this SCR start conducting. Okay, so obviously drop here at this resistance should be equal or more than that threshold voltage, then only this will get turned on. Now if this drop at that stabilizing resistance R is less than threshold voltage, then obviously as it is not touching threshold voltage, your device will not get turned on. So there will not be an output voltage, there will not be output current. Okay, whole voltage will be blocked across the thyristor. Okay, now if you increase this voltage, okay, VGP, okay, if you increase this voltage, then and you increase it such that maximum point is will reach, just reach VGT. So what will happen? So this will increase at till this point. At this point, it is touching VGT, so device will get turned on. Okay, so as device will get turned on, obviously you will have to see next waveform. At this point, it is turning on, so see here downward. From here, you will get output voltage. Okay, again here no this particular VGP present, so no voltage. At this point again it is turning on, so again you will get gate voltage. And if it is having resistance load, resistive load, then this is a gate current in phase. Okay, across thyristor, when it is not conducting, there we can see voltage. When it is conducting, you can see zero voltage. When it is not conducting, you will get full voltage. Okay, so this is how we can see this is alpha equal to 90 degree, means at this particular instant 90. Now thing is, when you try to increase the firing angle above 90, means if you wish to switch on thyristor at the tip of that arrow, cursor arrow, you want to turn it on here, so you can't reach here. Okay, as soon as your this VGP will reach that threshold voltage, it will get turned on at 90, so you can't control it above 90. Okay, but you can control it below 90 if your waveform is having higher amplitude. Then what you can see, if it's amplitude high, it will start to raise from here only. So like that you can turn on at any point before 90. If it get turned on here, then obviously from here you will get output voltage. Okay, but anyhow you can't turn it on above 90 degree. Okay, because as soon as you will reach 90 degree, it will get turned on, and your waveform can't be like this. Okay, so this is how you can see, this is for alpha equal to 90, this for alpha is less than 90. Now this problem is addressed in RC firing circuit. Okay, this problem is overcome in RC firing circuit. How it is overcome? See here, in negative half cycle, this capacitor will get charged as lower plate positive and upper plate negative through diode D2. This is how it will charge. Are you getting? This is the waveform. See, in negative half cycle, capacitor is charged. Now what will happen? As positive half cycle will start, see here, here waveform will reduces and will reach to 0, and then it will rises in the opposite side. But what will happen with the capacitor? Capacitor is now fully charged, lower plate negative, upper positive, and capacitor can't change or instantaneously can't change its voltage. So what will happen? Capacitor will slowly, as waveform, this waveform, negative waveform reaches 0 and raise in opposite direction. Capacitor will also start charging from this particular point till this point, till as your waveform completely reach 0, capacitor voltage reduce little but. Okay, so OA is the voltage. Now from here your actual source voltage will start rising in a positive direction. Okay, so obviously capacitor voltage will also start rising in a positive direction. But already capacitor, when your source voltage is having 0 voltage, that time your capacitor is having OA voltage, large voltage, so it will slowly get discharged. Okay, so when this discharging take cut the VGT threshold voltage, at this point your device get turned on. Okay, so here you can see after it turning on, you can see the voltage like this. Okay, current will be also in phase with this resistive load, and thyristor voltage will be there when device is not conducting, when conducting 0 voltage. Okay, so in positive obstacle, this is how it will conduct from resistance to diode likewise. Are you getting? And capacitor voltage is playing a role of that R voltage, stabilizing voltage in R firing here. This particular role VG is playing by capacitor now. Are you getting? So by varying this resistance R, you can vary the charging time of capacitor C, and obviously you can control the output from 0 to 180. Okay. Here also they have shown, if here you can see firing angle is above 90. Now if I wish below 90,